Hello, good evening. A warm welcome all of you to the YouTube channel of Infinity Learn by Sri Chaitanya. I hope everyone can see and hear me properly. It's me Surya, your chemistry faculty from Infinity Learn. I will be here with you through the entire journey of JEE 2026. We can learn the chemistry in a better way and in an interesting way. Okay, in this particular session, we are going to discuss a chapter, Classification of Elements and Periodicity in Property. This is one of the most important chapters in our grade 11 class. Actually, this chapter is based on the two topics, that is, first one is the classification of elements, the second one, the periodicity of the elements in their properties. In this particular session, we are going to discuss the first part, that is classification of elements. Here are the learning outcome of this chapter, that is classification of elements. In the JEE Main exam, it will come for 4 marks. These are the major topics from the chapter, that is genesis of periodic classification, including Mendeleev's periodic table, modern periodic law, long form of the periodic table, and the nomenclature as well as classification of the elements. About 56% of weightage should be here from this topic, so be careful about this topic. It will be very easy, but you have to remember more. Okay, let us quickly start this topic first. Okay, this is the first basics of the periodic classification. There are some history behind the classification. These are they. You can see that some scientists are given here. This is the first one. Can anyone guess who is this? Okay, the first one, that is the Dobereiner, who is the scientist who first classified the elements according to their atomic weight. Then, due to some drawbacks or demerits, it rejected by some other scientists. The second one came, that is Newlands Law of Octaves. Again, it also has some drawbacks. Then finally come our Mendeleev, that is Dmitry Mendeleev. As we already know, he is the father of modern periodic table, right? Again, it has some all the demerits. The last one, who is the Henry Moseley, came with the modern periodic table. Okay, this is the genesis of periodic classification. We can see these all classification in detail in the next slides also. Okay, here is the first classification, that is Dobereiner's Triads. As you can see that he classified the elements in a set of 3 elements. Okay, the set of 3 elements. These set of 3 elements are known as triads. Right? He formed a set of 3 elements which show the similar chemical properties. And also he made a conclusion that if you are taking 3 elements, for example, if I am taking A, B and C. Okay, A, B and C are the 3 elements in a triad. He made a conclusion that the atomic weight of B, that is, the atomic weight of B is equal to the average atomic weights of first 2 elements, that is A and C. This will be the conclusion made by him. Also, it is said that the atomic weight of middle element, for example here B, of a triad was approximately the average of the atomic weight of other 2 elements. Right? Here are some examples of Dobereiner's triads. Here are some examples of Dobereiner triads. He have made 3 triads here. The first one is lithium, sodium and potassium. As you can see that whenever we are calculating the atomic weight of sodium, we can conclude that the average atomic weight of lithium and potassium are similar to that of the atomic weight of sodium, which means these triads obeys the laws of Dobereiner. Right? Similarly, you can calculate the second one also, that is calcium, strontium and barium. Similarly, chlorine, bromine and iodine. Right? Clear? Okay, this is the classification made by the Dobereiner. Again, this has some demerits along with some merits. As we can say that Dobereiner is the first scientist who grouped the elements according to their atomic weight. right? This is the major point of the Dobereiner triad. This is a major merit of that. Along with it has some demerits, right? Right. What is the demerit of the Dobereiner triads? We can say that all the known elements could not be fixed into the Dobereiner triads. For example, I can take in here, right? As we already know that fluorine, chlorine and bromine belongs to the same group, right? Halogen group. But when we are calculating the atomic weight of chlorine, right? If I am taking here for fluorine, the atomic weight of fluorine is 19 and for bromine it is 80, right? According to our Dobereiner's law, it says that the average atomic weight of second element will be equal to the, the average atomic weight of two elements will be equal to the weight of middle element, right? If I am taking here, that is 99 by 2, that is 48.5, right? According to the Dobereiner's law, it is found that the atomic weight of chlorine is approximately equal to 48.5. But in practice, the atomic weight of chlorine is 35.5. Right? Which means these three elements rules out the rule of or the law of Dobereiner triads. This is the major demerit of the Dobereiner triads. Clear? Okay, fine. Clear now? Okay, now the second scientist came, that is John Newlands. What he made? Again, he made the classification, that is the arrange the elements in the increasing order of their atomic weight. Arrange the increasing order of their atomic weight. And also he made the conclusion that the properties of every eighth element that are similar to the properties of first element, right? And also we can know that this Newlands, he is a musician as well as a scientist, and he made this relationship with same as that of the existing between a musical note and it as its octave. Let us see clearly. As you can see here, right, there will be musical notes in your Indian music, right? Sa, re, ga, ma, pa, da, ni, sa, right? Sa is repeating here, right, with different frequency. Similarly, here in the case of atomic classification also, the case of periodic classification also, you can see that every first element, for example here lithium, it shows resemblance with the properties of eighth element, that is first, second, third, fourth, fifth, sixth and seventh. Eighth element, that is sodium. Lithium has the same properties with the sodium. Similarly, beryllium has the same properties with magnesium and so on, right? Which means that it is similar to the musical note in the Indian music. So, he named this law as law of octaves. Clear? Okay. As you can see here, the clear names of Newlands octaves. Here, he arranged the elements in the increasing order of atomic weight. Increasing order of atomic weight, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Again, the eighth element, that is sodium, have the same properties that of the lithium, that is the first element. Then, if I am starting from the beryllium, right? 1, 2, 3, 4, 5, 6, 7, 8. This eighth element, magnesium, has the similar properties that of the beryllium. Similarly, every eighth element has the similar properties that of the first element. Boron with aluminium, carbon with silicate, nitrogen with phosphorus, oxygen with sulfur, fluorine with chlorine and so on. But as you can see here that this law of octaves is applicable up to calcium only, right? It fails to explain the higher elements. This is the major drawback of the Newlands law of octaves. Okay, the system worked only for lighter elements up to calcium and failed to explain the heavier elements, right? As you can see here that we already know about the noble gases, right? What do you mean by the noble gases? There will be a group 18 element in the periodic table, like here neon, argon, krypton, xenon, right? So on. These noble gases fail to explain this law, Newlands law of octaves. As according to this octaves now, if you are taking the 8th element here, if you are considering noble gases also, we can say that lithium has a resemblance in properties with neon. But in practice, neon is different from the lithium, which fails to explain the existence of noble gases in the periodic table. This is the major drawback of Newlands law of octaves. Clear? Okay, right? Now let me move to the next classification or next history. Here, one more scientist came, that is Dobereiner. This is the scientist. He has done the same work as done by the Mendeleev also. But Mendeleev's work, Dmitry Mendeleev, we already know that both Dobereiner and Dmitry Mendeleev done the same work, but the work of Mendeleev got first recognition before Dobereiner, right? We can see the classification of Dobereiner work here. He already classified the element in the form of a curve, which means that he calculated the atomic mass of elements with atomic volumes, right? He plotted a curve against atomic volume of elements with atomic weight, which means that atomic volume is the periodic properties of atomic weight. Let us see the plot here. Okay, as you can see here, this is a plot made by Dobereiner. Here, the atomic volume against atomic weight is given here. As you can see here, some of the elements are given here in the top position, right? Lithium, sodium, potassium, rubidium. This is not calcium, this is cesium, right? Cesium. Similarly, some of the elements like beryllium, magnesium, calcium, strontium are given in this position. Similarly, fluorine, chlorine, bromine, iodine are given in the another position, which means that the same elements at the similar position of the curve have the similar properties. Elements at the similar position have the similar properties, right? For example, if I am taking here the lithium, sodium, potassium, rubidium and cesium, right? These are the same group elements, have the similar properties, which means that these all elements are the same position of the curve, right? At the peak position, which have the similar property. And also we can see that this is the atomic volume versus atomic weight. These high peak position have the higher atomic volume, right? High peak position have the higher atomic volume. Similarly, we can classify the elements in the different positions, right? Here, lithium, sodium, potassium, rubidium and cesium, which belongs to first group elements, right? That is alkali metals. This is shown at the highest peak of the Dobereiner's curve. Similarly, as you can see here, that is fluorine, chlorine, bromine and iodine, that are the halogens. These are present in the ascending position, right? Ascending portion of the curve. Ascending portion of the curve. Similarly, the second group elements like beryllium, magnesium, calcium and strontium. Okay, beryllium, magnesium, calcium and strontium belongs to the descending portion of the curve. Descending portion of the curve. And at the minimal position of the curve, you can see that these are the transition elements. These are the classification of the elements made by the Dobereiner. He done in a graphical method, but our Dmitry Mendeleev done in a tabular method, right? This is the one of the major merits of the Dobereiner's work. Clear? Okay, now let me move to the major contribution made by the Mendeleev. Mendeleev in our periodic table, that is Mendeleev's periodic law. As you can see that already he arranged all the 63 known elements in the increasing order of atomic weight in a tabular form. Right? This is the major point of the Mendeleev periodic table. Similarly, he classified all the elements in the periodic table into 7 horizontal rows known as the periods and 8 vertical columns known as the groups. Right? He classified all the elements into 7 horizontal rows known as the periods and 8 vertical columns known as the groups. Right? Finally, he made a law that, Mendeleev's periodic law, that it states that the properties of elements are the periodic function of their atomic weights. Periodic function of their atomic weights. Which means as the atomic weights varies, the properties are also varies along with that. Right? This is the major contribution of Mendeleev's periodic law. Right? And he made an analysis based on the valency property. He made all the oxides of all the non-63 elements and classified all the elements into different groups. As you can see into the periodic table in the next slide. And also he predicted the properties of some undiscovered elements also. Yes, this is our Mendeleev's periodic table. As you can see here that he have made all the oxides of all the elements, right? Then divide all the elements into 8 different groups named as Roman numerals 1 to 8. Again, these groups are subdivided into A, B and so on. Right? And also while observing this periodic table now, you can see that he have left some spaces here. He have left some spaces here. And he predicted the properties of that elements also. As you can say that these element will show the properties similar to that of the boron. So he called this element as Eka boron. Right? Which are the properties similar to that of the boron. Similarly, this element have the properties similar to that of the aluminium. Hence he called it as Eka aluminium. Similarly here, these elements have the properties similar to that of the silicon. Therefore, it is named as Eka silicon. Okay, these are the major observations made by him. He already classified the all elements into 8 different groups and it is again subdivided depending upon their valency property. And he has left some spaces for undiscovered elements also and predicted their properties. Now we can see that the achievements of Mendeleev periodic table one by one. Okay, as I already mentioned that he arranged the all elements into 7 horizontal rows and 8 vertical columns, right? That is periods and groups. This is the first major point. The second one, again these 8 groups are subdivided into A and B and it is labeled by Roman numbers 1 to 8. Right? Next you can see that in the next slide you have clearly visible the periodic table. As you can see that The group 8 consists of 9 elements arranged in the triads. And the last one, there were many gaps left blank on the periodic table for new elements which were after discovered and placed there. And also you can see that here the noble gases are separated into a different group known as 0th group. Without disturbing the periodic table, right? Here the elements are arranged into different groups from 1 to 8 in the Roman numerals. It's again subdivided into A and B. And as you can see here, these are the spaces left by him. Later it is named by scandium, gallium and germanium, which is Eka boron. Okay, which is Eka boron, and gallium is Eka aluminium. And germanium is named as Eka silicon. And already mentioned that in the group 8 now, all the elements are classified into 9 elements are classified in the form of a triad. 3 elements, set of 3 elements, right? These are the major achievements observed by the Mendeleev in their periodic table, right? Clear? Now let us see the merits of Mendeleev's periodic table. That already mentioned that he have arranged the elements according to their atomic weight in a symmetrical manner, and also new elements were predicted as Mendeleev left space for those elements. Also, he have arranged or modified some atomic weights of some elements, for example beryllium. As you can see here, if I am taking beryllium here, in actual practice its atomic weight is 13.5. In order to find out the valency as 2, it will contain, he modified the atomic weight of beryllium as 9. This is the one of the major modification made by Mendeleev's periodic table. This is the one of the major merit also. Even though he have done many good contributions to the chemistry, but it has some drawbacks or demerits, right? We can check what are they. He have arranged all the 63 elements, right, into different groups, but he fails to explain the structure, fails to explain the position of the hydrogen. It is yet to be determined, and he was unable to locate the position of hydrogen atoms, right? This is the one of the major drawback of his periodic table contribution, right? Similarly, he fails to explain the existence of isotopes. As you can say that isotopes have the same atomic number but different mass numbers, right? He fails to explain the existence of isotopes also. This is the second demerit of the Mendeleev's periodic table. Then the third one, as you can see here, that we can see that in our modern periodic table there will be two series elements, right, in the F block element, that is lactanoids and actinoids. In the case of Mendeleev's periodic table, no, the actinoids and the lantanoids are not follow this periodic law. This is the another drawback of this element. And also you can see that in the case of here, you can see that in the first group element, this potassium and copper, right, they grouped into the same group, but it has the dissimilar properties. It does not have the similar properties. It does not have the similar property. Then also he classified these two elements into a single group. This is the one of the major drawback. And also we can see that here, this element, right, platinum, right, platinum and gold have the almost similar properties, but he failed to explain the existence of these elements in a single group. Gold has placed in the first group and platinum has placed in the A group, which fails to explain the existence of these two elements in a single group. This is the major drawbacks made by Mendeleev in their periodic table, right? In order to overcome these demerits made by Mendeleev, another scientist came, that is Moseley, that is Henry Moseley. He is an English physicist. He again classified the elements in their increasing order of atomic number. Increasing order of atomic number. This is the major contribution given by the Moseley. That is, he stated that the modern periodic law that the physical and chemical properties of the elements are periodic functions of their atomic numbers, which is against Mendeleev's periodic law, right? Mendeleev's periodic law was explained that all the physical and chemical properties of elements are the periodic functions of their atomic weight. But when Moseley came, sir, he said that it's not by the atomic weight. All the physical and chemical properties are the periodic functions of their atomic number only. Right? And also he classified the atomic elements or the elements according to their electronic configurations. In order to determine the properties of elements, he uses the electronic configuration. Again, same as the Mendeleev, he classified the whole elements into groups and periods. That is, the horizontal rows are known as the periods and the vertical columns are known as the groups or families. According to him, there will be 18 groups and 7 periods. Right? 18 groups and 7 periods. As you can see here, the long form of periodic table. Okay, just go through it. You can see that in the case of long form of periodic table, all the elements are representing with their electronic configuration, right? Electronic configuration. You can see that by calculating here, there will be 18 columns, that are the 18 groups, and 7 periods from here, 7 periods. Here, these 2 periods are same as that of the 6th and 7th period, right? This is the long form of periodic table. From the idea of periodic table, we can give the major features of the periodic table are the long form of the periodic table is based on the electronic configuration, right? The electronic configuration of the elements, which means the elements are arranged according to their increasing order of atomic numbers. This is the most important point about the modern periodic table, because again the elements are arranged in their increasing order of atomic number, which means based on the electronic configuration, right? And again, it contains 7 horizontal rows known as periods and 18 vertical columns known as groups, similar to Mendeleev also, right? And also we can say that in each group, if you are taking here, in each group, all the elements with same valence shell configuration are arranged together. All the elements with the same valence shell configuration are arranged in the same group. Similarly, in the case of periods also, the differentiating electron enters in the s orbital in the first element. As you can see here, right? The left side of the element, all the last electron are entered into the s orbital in the left hand side of the element. Similarly, in the case of here, the right hand side, all the last electrons are entered into the p orbital, right? So this is called as the p block elements, and these 2 group elements are known as the s block elements. Right. S orbital in the first element and p orbital in the last element. And you can see that the 14 elements from this period to here, from lanthanum, that is cerium to lutetium, this is belongs to one period, that is lanthanides. And again from actinium to here now 89, 19 to 103 elements, these are belongs to F block elements known as actinoids. These are the classification of these elements in the long form of the periodic table, right? Clear? Okay, as you can see here, this is the long form of periodic table as we are using now. You can see that here, this is the first and second group elements known as S block elements, which means the last electron always enters into the s orbital of these two elements. These group 1 elements are known as alkali metals. And the second group elements are known as the alkaline earth metals. Here from group 13 to 18, these elements are known as p block elements because the last electron is always enter into the p orbitals. Right? Group 13 to 18 elements are the p block elements. This first group is known as the boron family, and 14 group is known as the carbon family. The nitrogen group is known as the nitrogens or nitrogen family. Here it is chalcogens, this is the halogens, and the last one is the noble gases or inert gases. This is the classification of p block elements into different groups, right? Now, as you can see here now, there will be gap of elements, right? Group 3 to 12. These group 3 to 12 elements are known as the transition elements. Group 3 to 12 elements are known as the transition elements, which means that it have a transition from highly electropositive metals to highly electronegative non-metals, right? The classification between the S block elements and P block elements, there is a transition elements. This is the group 3 to 12 elements, transition elements. Then as you can see here that from here 57 to 19, this is again. These are two different series known as the lanthanoid series and actinoid series, which belongs to the F block elements, which means that the last electron is always enter into the F orbital of the each element, right? These are the F block elements. These are the F block elements. Also, you can see that these transition elements are also known as the D block elements. Why does it so? Because in the case of D block elements now, the last electron always enter to the D orbital. That's why they are also known as the D block elements. Right. These are the major classification of periodic table of elements into different blocks. Now you have to remember some important terms. That is first one. That is the representative elements. That is, both S and P block elements together are known as representative elements. S block and P block elements. Similarly, there is another term known as the transition element, as I already mentioned, right? The transition elements, that is also known as the D block elements. The third one, that is the inner transition elements. That is the F block elements. One more term you have to remember that is the trans uranium elements. Here you can see that after the uranium element, right? After the uranium element, these elements including neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendeleevium, nobelium and lawrencium. These elements are known as the transuranium elements. Question may ask from this particular topic, that is, you have to identify the element which is not a transuranium element. You have to remember all these elements known as the transuranium elements. These are the major terms you have to remember in a periodic table. Now let us practice some questions based on the topic that we have covered today. The first question is, which of the following is a Dobereiner's triad? Which of the following is a Dobereiner's triad? Here the options are given as lithium, sodium and potassium. The second one, iron, cobalt and nickel. Third one, ruthenium, rhodium and palladium. The last one, osmium, iridium and platinum. What will be the answer? Okay, option A will be the correct answer, that is lithium, sodium and potassium. As you can see that here, we already mentioned that the atomic weight of sodium, for example, in the case of lithium it is 7 and for potassium it is 39, right? The average of these two numbers will be the atomic weight of sodium, that is 23, which means lithium, sodium and potassium is an example of Dobereiner's triads. And also there is a point you have to remember that later on, after Dobereiner's conclusion, there will be made another observation that the iron, cobalt, nickel are also a form of triad. Have to be noted. Can also say that this one is also a triad, and also there will be 5 triads according to the Dobereiner. What are they? Lithium, sodium and potassium, and iron, cobalt, nickel, sulfur, selenium and tellurium, and calcium, strontium and barium. Four triads, right? 4 triads are given here by the Dobereiner triads. These 4 triads you have to be remember for your examination point of view, right? Here you can see that the option 1 will be the correct answer, that is lithium, sodium and potassium, which is the exact explanation of the Dobereiner triad, right? Clear? Now let me move to the next question. Here is the next question. According to the modern periodic table, we have to identify the element that does not belong to the same period of the remaining elements. Same period of the remaining elements. The options are given as platinum, osmium, iridium and palladium. Which one will be the answer? Yes, palladium, right, Rohan. Palladium will be the correct answer, right? As you can see here in the modern periodic table, right? The iridium, platinum belong to the same period, but only the palladium belong to the different period, right? Which means option D, right? Option D is the correct answer here. Clear? This is the latest question, came from our JEE Main 2025. You must have an idea about all the elements in the modern periodic table. It will be helpful for you to crack the JEE exams very easily, right? Clear? Okay, this is all from my side for today. I think I have covered the genesis of classification of periodic table, right? We have started from the Dobereiner triads to last one, that is the modern periodic table. I hope it was clear for everyone. If you have any doubt, you can ask now. Rohan, I got 98.9%. Yeah, great, congrats. Prepare well for your JEE advanced exam, right? All the best. Okay, right? This is all for today. And tomorrow onwards, we will start from the IUPAC nomenclature of all the elements having atomic number greater than 100. And also we studied about the broad classification of modern periodic table into different blocks, right? S blocks, P blocks, D blocks and F blocks very detailedly. Stay tuned with our channel. Do like, share and subscribe our YouTube channel. Share this particular session to your friends also. Bye bye, take care, all of you, good night.